if I were to have an assembly, and I'll open the assembly that I actually made for this. Here's my top level assembly. Now my top level assembly is going to look like this now. Okay, now there's a couple of steps ahead, and I'll backtrack a little. But here's my top level assembly. In it, there is now one skeleton. It's a skeleton assembly. I'll delve into that in a second. And then the assembly has in it primary sub-assembly for the design and development going forward. What might be design criteria. We'll get back to that. So if I open my skeleton assembly, you'll see that it is broken up now into sub-assemblies. So here's my main skeleton, the one that I started with originally, and that's going to be the driving skeleton, the overall configuration skeleton, main definitions, sub-assembly coordinate systems and the like. And then sub-assemblies of skeletons. In this case, let's look at here. They got the secondary hull skeleton. If I open it, you see that it is now getting started with some of the basic definition. It's got the what was that, the hanger? That's the hanger on the back. What is it?
Shuttle bay.
Yeah, shuttle bay. Thank you very much. And this goodie over here was that's some sort of phaser or something. Main sensor. Okay, beautiful. Okay, so the idea here is that I'm now compartmentalizing. Is that a word?
It is now.
It is now. The design criteria. And so you can break these up even into smaller design pieces. For example, if I look at the primary hull skeleton is divided now into two skeletons. What might be the, I don't know, this thing on the top. Capturing design criteria for sub-bits. Remember, this is a really big thing. And so we're going to divide it into smaller pieces, allowing different groups to focus on their different studies individually. Okay? And so it's divided. Now each one of these, let's look at this one for example. If I open the nacelle skeleton and I go to its default view, you'll see it is square to its own datum planes. If I look at it from the front, if I look at it from the top, look at it from the right side, it's squared up. But you're familiar with this particular assembly where this nacelle connects the warp drive to the secondary hull. It's at some screwy angle. That angle is defined in the top skeleton. If the top skeleton changes, this then would update. Yet its definition in its own orientation, its own coordinate system, is square. So you don't have the issue of dealing with angles and planes and curves that are always at some wonky angle to your construction planes. Okay, so the definition of the nacelle happens here. But how is it assembled? Let's go back to the skeleton assembly, and if I look at the nacelle and I edit its definition, remember the first skeleton is assembled by default. Any subsequent skeleton is assembled to the previous skeletons. And so in this case, the placement is by coordinate system. So the default coordinate system of the nacelle skele is assembled to the nacelle coordinate system in the top level. You follow? So that means that it on itself might not change, even though its placement may, allowing for great flexibility with respect to when and what gets released at what time. Let's look at where that coordinate system was defined. That's a good question. Where did that coordinate system come from? I showed them quickly. I didn't talk about it much. Here's the nacelle coordinate system. You can see it down there. And if I edit its definition, you see it's a coordinate system at the end of that definition curve, and its orientation is with respect to the centerline axis of the vehicle, as well as the upper side in the warp drive, if you follow. So the Z is always pointing towards where the warp drive is. So if the warp drive moves in some way, the nacelle will always stay pointed to it. The coordinate system is not at 90 or 180 or any specific number. It is 100% geometrically driven. 100% geometrically driven, such that, as a matter of fact, let's make some changes. See the sketch up there in the warp drive is sketch number 7. If I edit that sketch, because right now it's at these numbers. If I edit that sketch, let's say I drag this, can I drag this over? Yeah. See how I can drag it over and the warp drive moves with it, giving me 100% flexibility. And you'll notice that the nacelle coordinate system shifts too, all the time updated. So it's not something I calculated. I simply said, if the nacelle is here, the coordinate system points to it. If the warp drive goes out this way, that's what has to happen, and we can make that go on. Okay, I did skip a step. Let me go back. I can see that is actually causing confusion. So if I let's go to the NCC 1701. This is my top skeleton. Actually, we'll go further. Let's go to the SSE assembly, which I closed. Okay, so let's open it. It's going to be in session SSE. So this is the brand new top level skeleton that I created today. And I'm going to delete both of these.
That's the top level skeleton or the top level assembly?
This is the top level assembly. Did I say skeleton?
Yeah.
I meant top level assembly. So this is the top level assembly. And so what I'm going to do here is I'm going to create a new component. The component that I'm going to create is a skeleton model that is a motion scale. And this is where I give it a name. And what it does is it creates a skeleton that's an assembly. I'll open it. And if you assemble a skeleton part, which is this one, if you assemble a skeleton part into a motion skeleton, it's a component. So if I assemble another skeleton, let's add the warp skeleton. If I add the warp skeleton, I assemble it by its default, the warp's default, to the warp scale in the previous overall scale, you see. It's a lot more simple this way, a lot more straightforward, although you might be thinking it's got to be more complicated than that. It's not. It is kind of awkward that you have to create an assembly first, and the only way to create a skeleton assembly is through component create, skeleton model, motion. But once you've got that in place, I then can build my skeleton assembly with any other skeleton models. I can't put any components in a skeleton, but you don't want to. Only skeletons go here. Once more, if I create a new component, it will create a skeleton model of its own. No matter what, I'm only creating skeleton models, and I assemble them however I want to. And so if I go now to my top level assembly, which is the NCC 1701, this is the top mother, there's only one skeleton in it. And it's that one skeleton that is an assembly. And it is including all the other skeleton models. This gives me one place to pull all the skeletons together, to make a drawing, to make a layout, to go to design reviews, and all those things. Nice.